Okay, I'm going to be going over Unit 10. I'm in the Unit 10 note packet, and I'm looking at day 1. And Unit 10 is all about limits, which is actually the beginning of calculus. And for day 1, every limit that we're going to look at comes from a graph. Up top in the box, I have the formal definition of a limit. But what we should know when we're asked to find a limit, what we're looking for is as x gets closer and closer to some point, it happens to be c, but let's say as an x value gets closer and closer to some point, from the left and from the right side, our limit is actually going to be the y value. In the definition, we say then the limit of f of x as x approaches c is L. It's kind of wordy, but I'll explain as we go through it. The notation for a limit is going to look like this right here. The way that we say this out loud is the limit as x approaches c of f of x equals L. So let's just take a look at the function that we're given in this graph right here. And we'll just jump in and start seeing how we can do here. So problem number 1 asks us to find f of negative 4. And so if I'm looking for f of negative 4, that's not calculus. That's just go on my graph and go to negative 4 and see what I'm up at. But there's a problem here because there's no point. It's an open circle. So I'm actually going to say that f of negative 4 is undefined. There's no value there. Now, number 2, this is actually our first limit problem. It says, find the limit as x approaches negative 4 from the left. That little minus sign right there looks like an exponent. If there's a minus, that means come from the left. So I'm going to look on my graph and I'm going to look at x is negative 4. And I'm going to imagine coming in from the left side. So I'm going to start on the left side of my paper, and I'm going to come in until my x value gets close to negative 4. And I want to know, what does the y value get really close to? So even though there's an open circle there, as I move in from the left, my y value gets really close to the number 2. So I say that my answer for the limit is 2. Number 3 says find the limit as x approaches negative 4, but this time there's a plus sign, so that means coming from the right. So here's negative 4, and I'm going to start on the right side of negative 4, anywhere over here on the right side of negative 4, and I'm going to trace in, starting on the right, coming in, until my x value gets close to negative 4. As I come in, as my x value gets close to negative 4, my y value gets close to 2. So my limit would be 2. If ever the left-hand limit, this was the left, and the right-hand limit are the same value. What that means is that the actual limit, notice number 4 does not have a little plus or minus, it just says the limit as x approaches negative 4 of f of x will also be 2. So if these numbers are the same, it will always be your actual limit. Let's try working around a different number. Number 5 is talking about 1. So problem number 5 says find f of 1. So to find f of 1, again, this is not calculus. I'm just going to come here to 1, and I'm going to look up and down until I find my point. And I see my point at 4. So f of 1 is 4. Now I'm going to go to number 6. And it says find the limit as x approaches 1 from the left. So here's 1. I'm going to start on the left-hand side, and I'm going to trace in. And as x approaches 1 coming in from the left-hand side, my y value goes to 4. Now I'm going to do number 7. Starting at 1, well, not starting at 1. It says the limit as x approaches 1 with a little plus sign, so that means from the right. So here's x is 1, and I'm going to start on the right side. And I'm going to trace in. And as x approaches 1, coming in from the left side, even though it's an open circle, my y value is negative 2. It's totally fine for an open circle to be the answer to a limit, because a limit just means what is y getting really, really close to. Now, my left-hand limit was 4. My right-hand limit was negative 2. In order for a limit to exist, like this is the actual limit over here, number 8, in order for it to exist, it has to go to the same number from the left and from the right. So if it doesn't, then what we say is the limit does not exist, or we say DNE. Okay, let's try number 9. If you want to press pause and try number 9 on your own, you can, and then come back in. I'll go through. This one says f of 6. So as when x is 6, 2. Okay, now we're going to find the limit as x approaches 6 from the left-hand side. So here's 6. Something to note is that a limit can never just be a random point. So if you ever see just a random dot, it cannot be the answer to a limit. And the reason is because in order for a limit to exist, it has to come from the left and come from the right. So it can't just be a random point. So this one says, find the limit as x approaches 6 from the left. Well, if I start on the left side and come up till x is 6, my y value gets close to 5. Find the limit as x approaches 6 coming from the right side. So I come on the right side, come into x is 6, my y value is 5. Again, it's okay for the answer to a limit to be a whole. The answer to a limit can never be a point because the limit has to come from a side. Now, in order for the actual limit to exist, remember we said if these two numbers are the same, that's going to be my answer to my actual limit. My limit is x approaches 6 of f of x is 5 because I have to come from both sides and come in as x is 6, my y value is getting close to 5. Okay, so now let's look at the bottom of our paper. And at the bottom of our paper, we have a graph that has asymptotes in it. And the type of questions I'm asking you are pretty similar to what I asked you up top, but this time we're looking at asymptotes. And so when I look at this problem, it says find the limit as x approaches 3 from the left-hand side. So I come on my graph and I come to 3, which is right here. There's an asymptote. And if I start on the left-hand side because of that little minus sign, we start on the left and I trace in, I can see that as x goes to 3, my y value goes up and up and up and up and up and up forever. And so I say my answer is infinity. Number 14 says find the limit as x approaches 3 coming from the right. So I'm looking at x is 3. I'm going to come on the right side, which happens to be this downward parabola, and I'm going to trace it in. So I'm going to trace, and as x approaches 3 coming from the right side, as my x value gets closer and closer to 3, my y value is going all the way down, and so I say negative infinity. Now for the limit as x approaches 3, well, those are different numbers. So we had talked about before, if they're different numbers, we say does not exist. But even if I just look at my graph, from the left I'm going up, from the right I'm going down, I'm not approaching the same number from the left and the right, so I say does not exist. Okay, number 16, find the limit as x approaches 6. 6 is this other asymptote from the left. Well, here's 6. If I start on the left, I'm on this downward facing parabola. And as x approaches 6, my y value is going down to negative infinity. As x approaches 6 from the right side, so from the right side, my y value is going down, so I say negative infinity. Now, number 18 is something to pay attention to. It says, what is the limit as x approaches 6? Well, there's two thoughts on this. One thing is to say, well, those both said negative infinity. They were both coming in from both sides. We were going down to negative infinity. So I can say negative infinity. Or, and this is something that's not agreed upon in calculus. In fact, it's different depending on which textbook you look at. Some people say, well, the limit has to actually be a value. And negative infinity is not a real value. It's not coming close to something because that's not an actual value. So for a actual limit, if the answer were infinity or negative infinity, an acceptable answer would also be does not exist. And so what I put up here was that one-sided limits, which would be these two, can have an answer of negative infinity or infinity. So the one-sided limits is totally fine. But for a two-sided limit, and that just means the actual limit without a little plus or minus, you could say your answer was infinity or negative infinity or does not exist. Either answer would be completely acceptable for calculus. Okay, if we flip over onto the back, the directions say find the limit as x approaches a from the right, a from the left, and just the limit as x approaches a. And this time I'm not given a graph, I'm given what's called a piecewise function because there's more than one piece, there's two pieces to it. And so what we're going to do on today's notes is we're going to graph the function to help us. And so to graph my function, just going to set up an xy axis. And 0 seems to be a key point on there because I see a lot of stuff happening at 0. Now, if I was going to graph this top function, okay, when I look at that top function, I know that that's a line. I know that it's in the form mx plus b, so I'm fairly confident in how to graph that without making a table of values. So my y values, my b value is -1, so I'd start down at -1. And then my slope is 2. So let me just put some dashes on here. My slope is 2. So from there, I'm supposed to go up 2 over 1. Or I could go down 2 over 1. And it's a straight line, so this would just go on and on forever. But before I connect up my points, I have to look at my restriction. And it says only graph this line when x is less than 0. So I can't graph anything over here. I can only graph it over here. I can only look at this portion of it. Another important thing to note is there was no or equal to sign here. So right here, when x was 0, I'm actually going to make it an open circle. And that's what that top graph looks like. Now this bottom graph, when I glance at this, I know it's a parabola because we learned that in the last unit. I see an x squared. And instead of rearranging this equation of the parabola, what I'm going to do is I'm going to make an xy table. That's going to be the most helpful thing for me. And I'm only supposed to look at this when x is greater than or equal to 0. So maybe let's put 0, 1, and 2 and see what happens. If I plug 0 into here, 0, 0, I get -1. So 0, -1. And I actually get to fill it in because it says or equal to. So notice how that just filled in the other circle that was open. If I put 1 into here, I get 1 plus 4 minus 1, which is 4. So at 1, I'm up here at 4. And I could put 2 in, but I'm going to get a pretty large number. I'm just going to connect my dots and know that that's going to look like a parabola that's opening up. So now I'm ready to answer my question. My first question is, what is the limit as x approaches 0 from the left? Now, when you write out limits, notation-wise, you have to put something next to this. You can't just say limit. And we're supposed to be defining the limit of f of x. So it's very important that you put f of x right there. And if I look at my graph, there's the graph of f of x. As we approach 0 from the left, my y value is -1. Now let's find the limit as x approaches 0 from the right of f of x. So here's x is 0 coming in from the right side. We're also down at -1. And therefore, the limit as x approaches 0 of f of x must also be -1. Okay, let's try number 20. Number 20 has 3 pieces to the function. Piecewise graph with 3 things. So I'm going to set up my xy axis. I notice that 2 and 6 appear to be pretty important numbers according to the way that the piecewise function is defined. So the first thing that I'm going to graph is this right here. And I know that that's a line, and I'm supposed to only graph that less than 2. So if I was graphing this line, I recognize it being y equals mx plus b. And so I would start up at 2. And my slope is 1, so I would go up 1 over 1, up 1 over 1, and I would stop right here. And the reason that I would stop right there is because it says only graph this when x is less than 2. My next part of the piecewise function just says the number 2. Well, if I was graphing y equals 2, All that is a horizontal line at y is 2. And I'm supposed to graph that between x is 2 and x is 6. And I'm going to have closed circles because of the or equal to, and closed circles because of the or equal to. And then the last part of my piecewise function is this, which is a straight line. All lines are straight, but it is a line. But I'm not going to do my mx plus b. I'm going to make a table for this one, just because it says only graph this when x is greater than 6, or greater than 6. So even though it doesn't say or equal to 6, I'm going to put 6 on my table. If I subbed 6 in here, 14 minus 12 is 2. And so at 6 comma 2, I'm going to make an open circle. I know it's already filled in by what I graphed in green, but I'm going to put an open circle here. I'll graph one more point. 7. 7 times 2 is 14. 14 minus 14 is 0. And so this is a line, and it's going to look like that. So those are my 3 pieces to this piecewise function. If I have to answer these questions, find the limit as x approaches 6 from the left of f of x. I'll just set it up. The limit as x approaches 6 from the right of f of x, and the limit as x approaches 6 of f of x. Those are the 3 questions that are being asked. We're going to look at our graph to help us. So as x approaches 6 from the left-hand side, I'm up at 2. As x approaches 6 coming in from the right-hand side, oh, I'm also up at 2. And therefore the limit as x approaches 6 of f of x is 2. Okay, let's try 21. Number 21, again, I have 3 pieces to my piecewise function. Actually, I'm noticing that number 21 and number 20 are exactly the same. So you guys get a little break here. Number 21 and 20 are, oh, they're not exactly the same. I take that back. If you look closely, 20 and 21's equations are the same, which is nice because it's going to be the same graph as above. But we're being asked to evaluate everything at the value of 2, at the x value of 2. So we're going to use this graph to help us answer these questions. The limit as x approaches 2 from the left of f of x. The limit as x approaches 2 from the right of f of x. And the limit as x approaches 2 in general of f of x. So let's look at the graph from number 20 to help us. Well, as x approaches 2, so I start at 2, coming from the left. So start on the left side and trace in. If I trace in from the left side, it looks like I'm approaching this open circle, which was up at 4. As x approaches 2, coming from the right side, I'm up at a y value of 2. And because the left and the right limits are not equal to each other, the left side was 4, the right side was 2, I say that the actual limit does not exist. Okay, let's try one last one, number 22. And I'm going to graph, there's 3 pieces to this, and it appears that along the x-axis, the important numbers are 0 through 4 at least. So I'm noticing that my first equation is a parabola. That's going to be a parabola. If you'd like, you can make a table to help you figure out what values we're supposed to put on there. It does say x is less than 0, so when I choose some x values to plug in, I would pick a 0 and maybe some values that are less than 0, and I'd plug them in. If I put 0 into here, I get -3. Now, because it doesn't say or equal to, I'm going to make a note that when I graph that, I'm going to graph it as an open circle. So 0, -3 is an open circle. Okay. Now, if I put -1 in, -1 squared is +1, and 1 minus 3 is -2. So 1, -2. Oops. I take that back. I plotted it in the wrong spot. -1, -2. let's come over here to the left, -1, -2. And if I were to put -2 in, -2 squared is 4. 4 minus 3 is 1. So I have -2, comma 1. And I'm just looking at this portion of the parabola. Okay. Now I'm going to move on to my next piece. My next piece of the piecewise function just says y equals -3. And all that's going to be is just a horizontal line down here at -3. And it's going to happen between 0 and 4. So I will fill this in and make a horizontal line all the way from 0 to 4, and I'll close in both sides. And then I'm going to move on to my third piece of the piecewise function. This right here, I'll make a table for that. If you know what that graph looks like and you can graph it without a table, that's totally fine. And it says x is greater than 4. So maybe I'll pick 4, 5, that should be enough. I know that it's going to be a line. So once I get at least 2 points, I can just extend my line. If I put 4 in here, 2 times 4 is 8. 8 minus 5 is 3. I'm going to put that as an open circle when I graph it. Let's put 5 in. 2 times 5 is 10. 10 minus 5 is 5. So when I go to graph, I'm going to have 4, 3 as an open circle. I'm going to have 5, 5 as a closed circle, and this is just going to be a straight line going off like this. And now that it's graphed, we can answer our 3 questions. So the first question is, what is the limit as x approaches 0 from the left? Make sure when you're writing this out that you always use good notation, that you write down the limit as x approaches 0 with a little minus sign of f of x. You cannot forget this piece right here. Then I have to find the limit as x approaches 0 from the right of f of x and the limit as x approaches 0 of f of x. So let's look at our graph. Let's look at our graph and see what happens. As x approaches 0 from the left side, we're down at -3. As x approaches 0, coming from the right side, we're also down at -3. And then hopefully we know that if the left-hand limit and the right-hand limit are the same exact number, then that is the answer to the actual limit. So after watching this video, go ahead and give your math space homework a try. I hope that helped.